Hi, I'm Doug Black. I'm editor-in-chief of Inside HPC. And today we're talking with a member of the Dell Technologies HPC Community. He is Flavio Villanustre. He is Vice President of Technology and Chief Information Security Officer at LexisNexis, as well as Vice President at HPC Systems, which is a DBA of LexisNexis. So, Flavio, great to see you today. Tell us a little bit about your background in HPC and about your responsibilities at LexisNexis.
Doug, thank you very much for inviting me. It's a pleasure to be here. And certainly, I have been, first of all, in technology for a very long time, for several decades now. And I have been involved in almost every area of technology. And certainly, HPC has been one of those. Currently, I am VP of Technology and CISO for LexisNexis Risk Solutions. And I also lead our open source HPC Systems initiative. This is our HPC-based big data platform. We originally designed and developed this platform back in the late 90s, and we continue to evolve, of course, this platform over the last 20 years or so. We have made it open source almost a decade ago, and now we have an open source community that is also helping to push the envelope in this platform as well. When we originally designed this platform, no other platforms existed to do big data, really. This big data was not even a novelty back then. And we built and designed this based on what we knew about the HPC world. So things like distributed compute, parallel processing, divide and conquer approaches, and message passing interfaces are at the core of the platform that we developed. As I said before, all of this evolved over 2 decades. The same principles are used, but of course, technology has become far more sophisticated, but it's still there. It's still that HPC platform that gave inception to our HPC systems big data platform.
Okay. So as I understand it, you have both internal and external customers using the HPC platform. How do the two groups of users overlap, and how do they differ in their use of HPC?
That is a very good question, and it is true that we have two types of users. On one side, we as LexisNexis Risk Solutions are probably one of the largest user of HPC systems. We use this platform to build all of our data services. And just, I should probably clarify this, the platform has two main components. One component that does big data integration, that component is called Thor, like the Nordic god of thunder that has the big hammer to hammer data into submission. This is for data integration. And then the other component is the data delivery system called Roxy, which provides real-time access to these very large data stores, and also for real-time analytics, machine learning, and other things. Now, on one side, it is us using the platform to provide our data service to our customers. On the other hand, the platform is open source and free, so many other organizations have adopted the platform to do their own data processing. In some cases, the type of usage, the usage profile of the platform is similar, and from what we know of some of those companies, because they share with us, what they do is fairly similar to what we do in some ways. In other cases, it is completely different to what we do. So in many cases, they manage to push the envelope on the platform because they have found novel applications that they could use the platform for. And that's always a refreshing perspective, because sometimes you can see how people have found ways to use what you have built, even if you didn't think that it could be possible before. So it's quite interesting.
Yeah, well, tell us about the scale of your big data infrastructure environment in terms of compute nodes, server nodes, and the amount of data that the environment incorporates.
Absolutely, that would be good to say. So we have our environments are fairly large. We have several of those environments. The total number of nodes across all of the environments is probably close to 20, 25,000, maybe 30,000 nodes. And the data that they handle is in the range of petabytes, right? This is many petabytes of data across all of them. It is interesting to mention that we have 25 or 30,000 nodes but we have been very efficient in managing these nodes, so we can manage all of this large infrastructure in a way that is consistent across all of these nodes and all of these systems with just a handful of administrators. And this is due to heavy automation, centralized deployments, and other best practices that we've been doing for a long time. Nowadays, you can see how some people are starting to discover these techniques, and they are applying them to like public cloud environments. But because of our need, and sometimes needs are driving discovery and innovation, we've been doing this for a long time, and it's been a very positive experience. It makes handling tens of thousands of computers almost a trivial task.
Yeah, amazing. Well, can you talk about some of the most demanding big data jobs your external customers put your infrastructure to?
That's a very good question. So, interestingly enough, when we designed the platform, we designed it for our own use. So we said, well, this platform needs to be able to integrate data, and to do this integration, we need something that can run these huge jobs, typically one job at a time, and build this consistent view of the world based on the data that is received. And we need also this platform that will do the data delivery in real time, so you can search using that real-time platform in a highly concurrent way, many users at the same time with very predictable latencies, and grab data from that, perhaps enrich the data as you're delivering it, and deliver the data. But this is not the way everyone uses the platform out there. So we have seen organizations pushing the envelope in doing particular types of analytics, including deep learning analytics on the platform, which is quite demanding. It certainly pushes the envelope in areas that might require to rethink what you consider a balanced system, your deployment architecture. Others have used the platform for real-time use. I always mention this company called Guard Hat, which develops these hard hats that have electronics inside, and these are meant to help with safety in industrial environments. So workers can wear these hats, and the hats will, in real time, collect data about the environment. And you can imagine, if you have many of these workers, you have tons of data coming in real time. Does processing analytics and returns back things like geofencing. Is this worker getting too close to a dangerous area? Is the level of carbon monoxide too high in the environment? Is the temperature getting too high? Are there too many workers in a particular area that cannot withstand this many workers at the same time? And on and on. All of this using HPC systems, the platform behind the scenes, and doing it in real time, which is quite challenging because there are many other factors involved here: latency to the transmission from the hats to the systems, the integration of that data in real time, building these dynamic thresholds to alert on certain things. So these are interesting new challenges that we found quite useful to tune our platform in a way that becomes far more effective to deal with this type of real-time problems.
Yeah, amazing stuff. So I think you've already answered this to some extent, but from your perspective, how have HPC big data workloads that you're involved with changed over time, and how has cluster or HPC technology evolved to support those workloads?
It has changed dramatically over the last 2 decades or so. It is the amount of perspective that you gain by just being in the same area for a long time, same domain, is significant. When we started doing this, when we look at what type of technologies we would use, we were trying to decide, for example, among hardware with maybe 1 or 2 CPUs with maybe 1 core per CPU, perhaps a couple if you were lucky and had SMP-enabled systems. You were looking at hard drives that were normally smaller than maybe 10 gigabytes, and you couldn't hold more than 2 gigabytes, or maybe at most 3 or 4 gigabytes per server of memory. Your bandwidth to the network used to be maybe fast Ethernet, so 100 megabits. and you were limited to in many aspects, including your thermal budget on the systems, on how much you could, how densely you could pack these systems. Now wait these last 20 years, and now look back and you see what we have today. And many of these, or every one of these variables have changed dramatically, and systems and things are orders of magnitude better today. Now, of course, this is not an easy transition. It's not that things were just smoothly moving from one generation to the next. Many of the generational changes that we've seen, we required the ways of changing what we were doing. One of those was the break with the Moore's law, when single core systems couldn't be any faster, and we started being pushed to using multi-core. These things require rethinking the way we do things, but we took very early a decision, which was to create an abstraction layer between the user and the system underneath. This is a programming language called ECL. So if you code ECL, and that's the core language used for the platform, you can use the same exact program that you coded 20 years ago in a platform running on today's hardware. And the system that will run that program hundreds, thousands of times faster, but still you won't be forced to change a single line of code, which is quite important. But the needs have changed as well. Data has grown significantly, and what we used to consider large data back then, eventually called big data, was probably a few terabytes of data. Nowadays, you're talking about several petabytes of data. This might still not be large enough in today's standards. So it is interesting that also not only the hardware to support this growth has changed, also the demands have changed as well.
Yeah. Well, tell us about some of the Dell platforms you use and why you rely on Dell as your vendor.
We currently use the FX line of blades, or flexible blades, that Dell provides. But yes, I should probably refer to the reasons why we rely still on Dell after decades of relying on Dell, of course. If there are a few important characteristics of a hardware vendor that we look for, and Dell has been meeting all of these over the years. Certainly, one that seems to be a trivial need for people that buy one or two servers at a time is a critical need for us when we buy tens of thousands of servers. And this is consistency across the platform. Many times, small discrepancies, maybe the firmware version for your SCSI controller is different than just making this up, or the version of the software running your NIC driver is different, or the hardware version of that NIC driver is different. If you have one or two servers, well, you can work around the things, and maybe you can adjust parameters in the operating system, and you can get away with it. If you need to run tens of thousands of servers in an exactly consistent way, having these discrepancies can be a killer factor. You might need to be forced to go and flash every firmware in every system at once, or maybe reliability of components. We had, in some cases, cases where a component wasn't reliable enough, and after a while, the component would fail with other vendors, which we have not seen with Dell. And every time we had an issue with Dell, Dell has stood behind the hardware that they sold and beyond that, which has been always a very, very positive experience. It's hard to say the same thing from all vendors, unfortunately, but Dell has been there. And of course, technical support, the ability to ensure that Dell's roadmap is always based on what customers like us require is also quite important. Every time Dell comes up with a new generation of hardware, and we look at the new generation, we see how the generation is reflecting some of the needs that we expressed before. It is not that someone just goes to the back room, comes up with some ideas, and then they implement and try to sell that. It is that they are listening to the customers and looking at what the needs of tomorrow will be to build the next generation. That's, again, it's something that is extremely important to us.
Okay, great. Well, thanks so much for your time and your insights today, Flavio, and we'll talk with you again soon.
Thank you very much, Lai.